Whenever a C++ program or a C program is executed, it will occupy certain memory, and that memory space is divided into four parts. The parts are data area, code area, stack area, and heap area or free pool area. Your functions of C language or C++ language are loaded into stack area. If you want to allocate the memory dynamically, I mean at runtime or at execution time, then you should allocate the memory from heap memory area. For doing this job, the C language provides the function like calloc, malloc, etc. In C++ language, a better facility is available. This is not an alternative arrangement. It is not repetition. The C++ provides you a more powerful mechanism for dynamic memory management. It is a better facility than C language. That facility which is available in C++ will do certain additional jobs too. In this session, I would like to show you how to dynamically allocate the memory using calloc function, that is traditional C style. In addition to this, I would like to show you the C++ style, that is using new and delete keywords of C++ language. Is it clear to you? The concepts like code area, data area, stack area, heap area, how your C functions manages the function stack, then dynamic memory allocation mechanism, etc. etc. I have discussed this concept in detail in my C tutor, namely the hottest C movie on the earth. It is a 50 hours movie and I have given really a detailed treatment to all these topics. Here I am just revising the concept. Let us see how to allocate memory from the heap memory area using the function calloc. Size of character is 1 byte. I want to allocate memory for 20 such data types, and that's why I return calloc in the bracket 20, comma, size of character. After that I use typecasting over here because the function calloc returns void data type, and that is why casting is necessary. I assign this value to a character pointer. So my character pointer PTR will point to the first memory location of the allocated memory space, first byte of the allocated memory. Okay. After that, I assign a string Rajiv Dharaskar to this pointer. After that, I am displaying the content of the variable to whom PTR is pointing, or in other words, content of the memory location to whom this PTR is pointing. Let us execute the program up to this step and see the output. R is displayed. So right now our pointer is pointing to the first memory location, that is first byte of the memory space which we have allocated dynamically. Let us increment this pointer and display again the content of pointer. Execute up to this one and see the output. Now we have incremented the pointer. So pointer is incremented by 1 byte because it is a character type of pointer, and character data type consume 1 byte, and that is why whenever we increment the pointer, the content of the pointer will be increased by 1 byte, and that is why this pointer will point to the second element of the string, and that is nothing but A, and that is why A is displayed over here. At last, we must free this allocated memory area using the function free. So how to use this function? Just write the name of the function, that is free, and inside the bracket mention the name of the pointer which we have used for dynamic memory allocation. Is it clear? Execute this step. Now we have freed the memory which we have allocated using the memory management function, namely calloc. The next step is really very important. After freeing the memory, we should not use that pointer in our program. Otherwise, that pointer will become stray pointer, and the stray pointers are really very dangerous. To avoid stray pointer complications, always initialize such pointers by null value. If you use this null pointer accidentally in your program, then that mistake can be easily identified. And that is why I initialize the pointer by null value. Let's revise what we have studied in this program. Using calloc, we have allocated 20 bytes heap memory area. We assign that one to the pointer. After that, pointer is initialized by the string Raju_. So pointer is pointing to the first character of the string, that is R, and that is why output of first cout is capital R. After incrementing PTR, it will point to the next character, that is A, and that is why output of this statement is small a. Is it clear to you? Let us analyze this statement. Here we have created character pointer. That character pointer will be created inside the function stack, and that function stack exists inside the stack area. Is it clear? After this, observe this part of the statement, that is function calloc. The calloc function will allocate 20 byte memory space inside the heap memory area. The pointer PTR is pointing to the first byte of that allocated memory space, and the content of the first byte is capital R, and that is why this statement display capital R. Is it clear to you? If you increment this pointer variable, then the content of PTR will be incremented by 1 byte. Understood this point? Always content of PTR is address, and that address will be incremented by 1 byte, and that is why PTR will point to the second byte of the allocated memory area. Is it clear to you? And that is why second cout statement is displaying A, that is content of second byte of the allocated memory space from the heap area. Is it clear to you? The function calloc is allocating the memory space to the pointer PTR at the time of execution, and that is why we say that we are allocating the memory dynamically. Observe one more point. This function, namely free, we have allocated the memory to the pointer PTR dynamically. So during the execution of the program, this memory space is reserved for pointer PTR. We cannot use this memory for any other purpose. Only PTR can access this memory space, and that is why after utilizing this space, this memory space, if you want to use this space for another purpose, then you should free this memory space, and that is why the function free is used to clear the memory space which is allocated to the pointer PTR. Is it clear to you?